everyone, this is Miss S from Excelsior Charter School, and today we're going to be covering Geometry Quarter 2, Quiz 2. And just like all the quizzes, we've changed the values and mixed them up a little bit. So let's go ahead and get started. Our first one here wants to know what additional information we need to know in order to prove the triangles are congruent by HL. HL, of course, means hypotenuse leg. And it is important to remember that the hypotenuse is always across from the right angle. So in order to know HL, we need the hypotenuse and we need a leg. And currently we know that this hypotenuse, ON, is congruent to this hypotenuse, PL. So what we really need to know is a leg. So we need a leg of one triangle, maybe LM, and we would need to know if it's congruent to a leg on the other triangle, maybe MN. That would be one thing we could know. We could also say that LM would be congruent to MO. That would also be okay, the other leg of the other triangle. And then our other leg on the left-hand triangle, PM, would need to be congruent to the same thing. Either MN or PM would have to be equal to MO. So those are the things that we would need to know in order to find the leg for the hypotenuse leg. And that's what we need to know to do HL. There's another question on your quiz that wants to know basically the same thing. How would you know you can do HL theorem without using CP/CTC? Remember, in order to have hypotenuse leg, you have to have a hypotenuse. So if they don't give you a hypotenuse, you can't do HL. So that will help you answer that question as well. And on to our next one. Which overlapping triangles are congruent by angle, side, angle? This is definitely a tricky question here. So if we're looking at all these angles, the only angle we actually know right now are these right angles here. So we definitely want to utilize those. And then when we need overlapping triangles, we have one angle, so we still need a side and another angle. It doesn't look like any of our sides overlap. However, we do have this angle right here that is in multiple triangles. So we might be able to use that as our second angle. So then we would need the side between them. So if we look here from this right angle to this angle, the side between those two is right here. And if we look at this right angle with this angle, the side between them is right there. So that's angle, side, angle in this triangle right here, which we could call LON. And I started with the one that we don't know. I went to the right angle and then to our single angle that we did know. And let's see here. In this other triangle, we have this right triangle and this angle here and this side, which would go in this yellow triangle here. So we want to start where we don't know the angle, which would be P. We go to the right angle M and then to our single angle N. So LON would be congruent to PMN by angle, side angle. All right, there's a few of these questions here. The triangles are congruent. Identify what they have in common. So it's pretty simple to just trace over each of the triangles here in two different colors. So here is our black triangle here, and then here is our red triangle here, and then you just look for where the colors overlap each other. And the answer in this case is side MN is congruent on both of those. It's common to both of those triangles. Here's another kind that you might find. So again, if you trace the triangles in different colors, here's a triangle HIK, and then I'll do this one here, KJI, and look to see where they overlap. And they overlap here at IK. So that would be where another side is overlapped. And a third kind here, similar to what we just did here, so I'll draw this one in blue. And then I'll draw this one here in black. Notice it doesn't go across the whole side. So none of my sides overlap here. So let's look at our angles and we'll find, oh, hey, this one right here is common to both. So that angle would be the common angle for both of those triangles. All right, this one wants us to solve for angle A and angle B. We can tell that this is an isosceles triangle because it says that this leg is congruent to this leg. And we know in an isosceles triangle, if you bisect the vertex angles like this is here, it always turns into a perpendicular angle there. So B would definitely be 90 degrees. And then, so that's 90. We also know, because it's an isosceles triangle, our two legs are the same. Our two base angles here are also the same. So this one over here is also 53. So in this top triangle up here, kind of in red that I've outlined here, we know two of those three angles, which means we can find the third by subtracting from 180. So 53 plus 90 plus angle A would have to equal 180 degrees. And when you do the math there, what you get is that A equals 37. All right, this is a proof here. Given that LM is congruent to MN, so here and here, we have an isosceles triangle, and angle LMP is congruent to angle NMP here and here, they want us to prove that MP bisects LN. So we've marked here what we've been given. We can also say that MP is congruent to MP because of the reflexive property. And now if we take a look at our left-hand triangle, I have side, angle, side. And if I take a look at my right-hand triangle, I have side, angle, side. So I can prove that triangle LMP is congruent to triangle NMP by side, angle, side. And once I have the two the triangles congruent to each other, we can prove that anything is congruent to any corresponding part by CP/CTC. So that means that I can prove that LP down here is congruent to PN, which means that now I have MP bisecting LN by definition of a bisector. All right. Our next one wants to know what the vertex angle of an isosceles triangle is with a base angle of 37. So here's a base angle of 37, which means the other base angle is also 37, and they want to know what x equals. So if I know two angles of a triangle, I can always find the third angle by adding them all up and setting them equal to 180, just like that. And when you do the math, you will get that x equals 106. So the vertex angle is 106. All right, in triangle LMN, LP is perpendicular to MN at P, and angle MLP equals angle PLN. And what type of triangle is LMN? So I'm just going to draw a triangle here, and I'm going to say that LMN, and I want to say that LP is perpendicular to LM at P. So this must be like this. And angle MLP here is congruent to angle PLN there, which makes LP an angle bisector, a perpendicular angle bisector, which makes this an isosceles triangle. All right, this one's the hardest one, I believe, on here. It says angle 1 is 7x minus 48, and angle 2 is 11x. They want you to solve for x. So this is definitely an isosceles triangle, which means that this is also angle 1 here. So you can add angle 1 and angle 2 together to get 180 degrees because they also form this line right here. So that's what you do. You set it equal 7x minus 48 plus 11x is going to equal 180, and then you solve it using algebra. And what you'll get is 18x minus 48. When you add the 7x and the 11x together, you add 48 to both sides, you'll get 18x equals 234. You divide both sides by 18, and you'll get x equals 13. So there you go, you guys. Good luck. I hope you guys all do great.